All right, let's rock and roll. Welcome to the Friday, 9 a.m., morning after the attendee party session, covering Exchange, deep dive into Exchange Server high availability. You know, it kind of makes me happy because I know whoever's here probably really wants to learn about high availability, or maybe you just never went to sleep last night and are looking for some place dimly lit to chill. I'll try not to talk too loud. So my name's Andrew Higginbotham. I'm a principal engineer for Dell's support and consulting organization, as well as a Microsoft MVP and an Exchange Microsoft Certified Master. Also, don't be shocked in thinking maybe you fell into some space-time void to 5 years ago. This actually is the year 2016, and we are talking about Exchange on-prem. Your responses are being recorded, so there you go. Actually, there's been about 4 or 5 sessions this week on-prem, some really good ones. The downside of this being Friday is I can't tell you to go watch something here, but you can certainly go watch them online. So throughout the presentation, I'll be recommending some really good sessions this week delivered by my colleagues and Microsoft product managers, program managers, that I think will really give you more details and insight into what I'm talking about here. So a lot of good stuff being recorded. So let's begin. So our agenda will be first going into a brief history of Exchange high availability to tell you, how we got here, and then also how high availability can affect your on-premises environment and how it kind of has enabled Office 365 to become what it is today. Then we'll talk about the new features in high availability, talk about some best practices and tips, and at the very end, I'll talk about some of the new Windows Server 2016 features revolving around HA and how they may affect Exchange. So this may be preferred architecture, this may be virtualized on SAN, depending on how you want to do it. And in my role doing both support and consulting for Dell, I kind of get to see just about every type of Exchange deployment between virtualized on SAN all the way to a lot of preferred architecture actually. So hopefully that's the insight I can provide to y'all. Best practices, what I've seen in the field, what I think works. So it's not just going to be, here's a feature, isn't it grand? It'll also be, why would you use that feature, and what benefit could it give your environment, no matter what architecture you're deployed as. Okay, history of HA, what I'm deeming the dark days. So before Exchange 2010, with the advent of the DAG, to achieve HA and DR, we were reliant upon other technologies, such as shared storage failover clustering. We still use Windows failover clustering, for sure, but there's no more shared storage, there's no more shared Exchange clustered resource. So it's a lot more simpler from the clustering perspective to achieve HA. And we've eliminated storage as a single point of failure since we went to the DAG-based model. Exchange 2007 had CCR clusters, but you were still just limited to 2 copies. Also, the product lacked any type of native means to achieve backup. You had to rely on backup technologies. Now, I'm not saying you have to go with Exchange native data protection, but it was really HA that triggered all these enhancements to where you could choose to not back up Exchange. You could use the native product features. And actually, Ross Smith's 2016 architecture session earlier in the week, he had a great slide talking about each Exchange built-in feature that enabled you to use native data protection. The DAG, lag copies, single item recovery, and so on. In these days, the product also lacked any type of built-in retention and compliance technologies. So you had to go with a third-party solution to achieve that. And then came the light. So with the DAG, we removed several points of failure by saying we're not going to rely on a single instance of a database. We can have up to 16 copies of our database spread throughout the entire world. Of course, you probably realize from a practical perspective, I've yet to see a customer that has 16 copies of a database, because there is a bandwidth cost every time you add an additional copy. And we'll talk about how that story is getting a little better here soon. But with the DAG, you had these options of not really needing RAID, because if a hard drive fails, as I said, you have many other copies of your database that can be activated in a matter of seconds. And we really went from hundreds of seconds to maybe tens of seconds or less in terms of how long failover takes now with the DAG. With this and all these other features enabled you to go without traditional backups if you wanted to. And really, Office 365 couldn't exist without the HA improvements. I mean, how are they going to back up everyone's mailbox when it's 50 plus gigs, right? How are they going to scale to the level they've scaled without the ability to go with physical server JBOD deployments that are easily scalable, right? So I don't think HA gets the credit it deserves in terms of all the features that enabled 365 to be what it is today. But they can also help your own environment, even if you're not going full preferred architecture. You know, some of these features you're really going to like. Also, performance improvements allowed the product to be run on big, cheap disks. I love this philosophy that Microsoft has that you're paid to work and be productive, not to sit there cleaning out your mailbox, right? So for that reason, they want to give you the biggest mailbox for the best cost. Excuse me. And as I mentioned, failovers and recoveries are now faster than ever. It's usually taking less than 30 seconds, sometimes in the teens of seconds. So most of the HA enhancements are centered around improving these capabilities. So the DAG, lag copies, and some of the clustering components, right? So what's new with Exchange HA? If you're not running preferred architecture, apologies for the next few slides, because these are going to involve lag copies. I imagine you're not going to be running lag copies unless you are on preferred architecture. Who's running lag copies, if you don't mind hands? That's a decent amount of folks in the audience. That's pretty cool. So if you're using lag copies, the idea with the lag copy is you can artificially delay the replaying of transaction logs into a particular copy of your database. This is your insurance policy, so if you have some type of massive data loss event in your environment, you can go to your lag, which should be up to 14 days, artificially kept behind, and you can use that to recover from. So Replay Lag Manager was introduced in 2013, but refined in 2016. It's the ability of Exchange to turn a lag copy into a highly available copy if needed. Why would it do that? Well, low disk space, physical corruption of the lag, it needs to replay to patch that corruption, or copy count. So say you have 4 copies of your databases. You have your active copy, you have 2 highly available passive copies, they're ready to go, they're up to date, and then you have a lag, so 4 copies of your database. What if you were to lose a couple of those copies and you were running with just 1 active and your lag? Well, if you were to lose that next copy, that lag database could take a long time to replay all those transaction logs into the database. That act of replaying those logs, it incurs a lot of random I/O, a lot of hit to disk, so it could be a matter of minutes or possibly hours, depending on storage performance, before that lag could be activated. So the DAG will sense these things and start playing down those logs proactively. However, when you're talking Replay Lag Manager and how you would enable it or tweak it, what you're doing is making a decision over whether you care more about availability or the retention of that lag, keeping it intact. As Ross Smith stated in the architecture session the other day, a lag you should never have to use it. It's more of an insurance policy. So in Microsoft eyes, they actually deem it okay to replay the lag in certain circumstances. Again, it's if you care more about availability or the retention of that lag. So Replay Lag Manager is enabled by default in CU1. But there's also this really cool enhancement to Replay Lag Manager called Deferred Lag Copy Playdown. The idea here is we're just going to make sure that the replaying of those transactional logs does not adversely impact the performance of any other databases that may be on that same set of spindles, right? As I just said, replaying of those logs incurs a performance hit. So we don't want the other people on those other database copies that may be on the same storage, the same disks, possibly. We don't want those to be adversely impacted. So deferred lag playdown will actually delay the replaying of those files. And each of these, there'll be a few slides on this, each of these can be controlled with either set database availability group or set mailbox database copy. So what parameters does it look for to defer playdown? The idea here is if we, and this is a graph of latency over time, if we needed to start replaying those transaction logs, if we saw that disk latency went over 35 milliseconds, we will defer the playdown. We'll stop replaying those logs because we don't want to adversely impact the other users on those spindles. Once latency drops back below 25 milliseconds, so remember, it stopped doing it at 35, it waits until it goes below 25 to continue the playdown. So the idea here is we're not actually impacting the overall performance of the databases sharing the spindles. How would you monitor Replay Lag Manager? You could look at the Crimson Channel event logs. And for those that don't know, Crimson Channel is kind of a code name since the Server 2008 days for the additional set of Windows event logs. So in Event Viewer, you have application, security, and system logs that we're all pretty familiar with. Below that, if you go into Applications and Services, you'll find the Crimson Channel logs. And if you drill down under Microsoft, Exchange, High Availability, you can see some of this logging that is created whenever Replay Lag Manager is triggered and all the actions it's taking. For instance, this is also where you could look to see what Managed Availability is doing on your server. And unfortunately, in the interest of time and some of the new features we wanted to talk about, I don't really go into Managed Availability in this session, but there really hasn't been too many changes there, so if any. So there's been, I think, a dozen or more Managed Availability sessions in past Tech Eds and MEC, so if you're interested, you can find those on channel9.msdn.com. If you did want to disable Replay Lag Manager, again, do it via Set Database Availability Group. And if you also wanted to disable Deferred Playdown, you can do that at the mailbox copy level. So with these, again, you're balancing high availability versus data retention, right? The things you can do there is you can control the minimum number of available copies before Replay Lag Manager will trigger. You can also control the low disk space threshold. In both instances, you just need to restart the DAG management service afterwards for it to take effect. So ultimately, your operational needs will determine how you want to play with this and what settings you want to use. So it's just one more customization you have now with HA. Another fairly recent change is the activation preference changes that came with CU2 in 2016. For these to be relevant, all servers within the DAG need to be at CU2. So historically, people have used the Redistribute Active Databases PowerShell script to balance the load in your DAG, so to speak, to where if you have certain database copies that are preferred to be active on certain nodes, you can move them around so they are active there. So if over time you experience some failovers or switchovers of some kind, and maybe your DAG isn't as balanced from a load distribution perspective as you would like it to be, historically you could run this script, maybe you set it as a scheduled task, to rebalance those database copies. Now with CU2, the DAG can do it itself. So it's a property of the DAG itself. So it is Set Database Availability Group, Preference Move Frequency. So by default, it works at every hour. So if you have CU2 or newer and you don't want this behavior, you can disable it using Set Database Availability Group. So anyone who was previously using the Redistribute script can remove your scheduled task if you wish and just let the DAG do it for you. Right? And as we go through the session, you'll find that there's a lot of value to having a balanced load distribution in your DAG from the disk performance perspective, CPU, memory, client connectivity perspective. Having a balanced DAG is really helpful. All right, so the big feature in 2016, and my favorite feature in Exchange 2016, it was promised at RTM, as Ross said, and then he said he promised it again at CU1, and then CU2, but CU3 it finally came here. So a bit of a history lesson, right? Every copy of a database that you generate incurs a penalty because of network utilization needed, right? If you have 4 copies of a database, you have your active copy and 3 passives. There's going to be 3 separate log streams, or replication log streams to be more accurate. There's 3 separate streams going there: active to passive 1, active to passive 2, active to passive 3. Right? So you're going to have a network throughput hit there. Unfortunately, ever since the days of 2010, when the DAG first came about, The content index that each passive copy must maintain, and what is used for searching, things like OA and Outlook in online mode and whatnot, and now in Outlook in 2016. Excuse me. That content index had to always reach across the network and talk to the active copy so that it can generate the content index itself locally. What that meant was the content index traffic actually was about equal to uncompressed replication traffic. Right? So it used a lot of network bandwidth. Well, I'm thrilled to say in 2016 CU3, the content indexes can be built locally instead. So you've eliminated that network traffic for content indexing. They're not here, but I'd like some claps for the product team. I contributed nothing to this, but it's pretty freaking cool. So, excuse me. So if you like your bandwidth, reclaim it by deploying 2016 CU3. And here's just this is a simplistic example to get, I guess, further explain the point of how it works and the savings you could get. I'll talk about why you would want to use the calculator in your own environment to get more actual numbers. But say DB1 generates 5 gig of transaction log a day, and it has 4 copies. Like the example I just gave, there's going to be 3 different replication streams there. So 15 gigs are going to traverse the network a day just for the one database. So before CU3, with the content indexing traffic, you could expect about 15 gigs worth of indexing traffic as well, so 30 gigs. With CU3, read from passive, you can eliminate the content index traffic entirely. With an important note, with lag copies, they must still, at this time at least, traverse the network and have the old behavior. So you're not going to be able to reclaim the utilization if you're using lag copies, which is why it's important to use the updated Exchange Server Role Requirements Calculator. It was updated last week when CU3 shipped. And you can see what type of savings you would get. So if you go on the inputs page of the calculator, at the very bottom, has anyone ever actually used this table? There's the replication per hour percentage table. Has everyone used that before? What that does is that populates the replication requirements section of the calculator. So it's one of the tables or tabs at the bottom. If you populate that, and you should do it accurately, as accurately as you can, it will tell you roughly how much network throughput you'll need for your design. And one easy way to just see the type of savings you'll get is populate the calculator to your environment specifications, and on the inputs page, first section there, at the very top you have the drop down where you can say, are you deploying for Exchange 2013 or 2016? So here I just took some default inputs, and at the top section here you'll find how it was set up with 2013. And when you select 2016, it assumes CU3 is enabled. And you'll see that for a database copy, I needed 1.33 megabits per second. However, now with an HA database copy in 2016 CU3, I would only need 0.55 megabits per second. However, notice that we still have the 1.33 number if we're using lag copies, because remember, they still have to go back over the WAN or the network and talk to the active copy. But I'll call out that in terms of total throughput required, we went from 3358 megabits per second down to 2370 megabits per second. And whether that seems a lot now to you, remember this would be for this environment per se, right? It all depends on your environment. But here we saw a 30% reduction. It's really important to accurately populate the calculator so you get an accurate reflection of the savings you'll see in your environment. So the way I would present this is if you're an admin and you want to have more ammo to go to management to deploy 2016, this is one thing you could show them. And if you're a consultant and you want to have that conversation with the customer and show them why, one of, in my opinion, is the biggest benefit of 2016, you can show them some of these bandwidth savings. And maybe you just kick back and relax and enjoy your saved bandwidth throughput. Or maybe you could consider a redesign and add additional HA copies to your environment and further increase your solution's total HA. It's whatever you want to do. You have choices. That's the cool thing about the new feature. And one last added benefit with this change, we should also be seeing even faster failover times. So some features introduced in 2013, but are still pretty cool. Auto reseed, as I like to call it, hot spare for your DAG. Who here is using auto reseed? Not too many folks, but so auto reseed came about as an answer to when 2010 came out and Microsoft was trying to promote the preferred architecture and not doing backups and then using JBOD storage. A lot of people complained saying, well, okay, if I have a single disk failure, now my mailbox database has gone from 4 copies down to 3. So its availability has been impacted. So until I am able to send someone out and replace the hard drive, my availability has been impacted. So Microsoft said, well, what if we could have a hot spare for your DAG where if a drive failed, the DAG was smart enough to detect it, format, switch around the new drive. It uses mount point, so it does kind of some trickeration there to point the databases to this new disk. And it'll automatically kick off a reseed for you. So if you have a disk failure on Friday evening, when you come back Monday morning, those database copies that would have been down have now been reseeded and are available with no administrative action whatsoever. So it's pretty cool. You can have multiple hot spares that you define. You configure it using set database availability group. A couple call-outs here. So the auto DAG database copies per volume must accurately reflect how many you're putting on a disk. So if you're running 4 database copies per disk, you should populate that with 4. It needs to be accurate in order for the logic to work. Now, one misconception I've seen is that the copies per volume needs to equal however many copies of the databases you're running. So if each of your databases has 4 copies, that means you should have to run 4 database copies per drive, per volume. That's not true. That's a recommendation in terms of balance and the best utilization of the feature. That's not a hard requirement. As long as the auto DAG database copies per volume is accurately configured to reflect how many database copies are on the volume, then it will work. So the other thing about them being equal to the number of database copies, it's just a recommendation. Loose truncation. We probably know the phrase, never leave a man behind. Well, maybe in some cases you might want to. You don't want one family member bringing the whole thing down, the whole family down, right? Loose truncation is, there's 2 things that can really cause logs to truncate in a DAG. Either you've performed an exchange-aware backup, or you're running circular logging in the DAG, also known as continuous replication circular logging, which ensures that every copy of a database has received a log first before it'll truncate it. Right? The downside of that is if you have one unhealthy database copy, it's going to cause all the other database copies not to truncate. Because obviously it knows that, hey, well, that copy needs this log in order to be healthy. We can't get rid of it until, database 2 over here has gotten it, or database 2, copy 3, or whatever. What loose truncation does, it says, well, we don't want that situation to result in you running out of disk space, which would be worse than just one copy going down. That could bring all of your copies down because they'll all run out of disk space likely. Historically, admins have seen this behavior where you have one copy that's going to be down for a while, and what they could do is they could just remove that passive copy. Say, forget about it, I'll reseed it later. Loose truncation does that automatically for you if you want it to. So given certain parameters, it has the ability to go in and just, it'll tell the other copies, go ahead and truncate your logs. That's fine. Go ahead, proceed forward, leave this guy behind. His copy will go into an unhealthy state, and you'll have to eventually reseed. But the benefit here is that you're not going to run out of disk space and bring them all down. So it's disabled by default, so if you want to play around with it, it's in the registry where it's configured, and there's a link at the bottom. And you can download these slides later. They have some links in the notes as well if you're curious about it. Apologies for using the bit.ly link shortener and not the aka.ms. Remember, this is an on-prem session. We had to do it on the cheap. We don't have any of that Office 365 internet money. So DAGs without administrative access points. This is really a 2012 R2 clustering feature that allows you to not really need a cluster name object or a cluster IP address. Show of hands real quick. Who here has ever had to troubleshoot? Already hands going up. I know, y'all know it. Who here has had to troubleshoot a situation where somebody deleted the cluster computer account and then their cluster died on them, right? They say, hey, this computer account has a decent amount of hands. This computer account, hasn't been used in a while. Let's delete it. Well, then it brings your whole cluster down. The thing is, a DAG doesn't need that, and not all clusters need that. No clients ever actually connect to the clustered IP or the clustered name, right? So you can create a DAG without that access point. The downside is if you wanted to manage the cluster, you'd have to use PowerShell. But with the DAG, the Exchange commandlets handle all the management for you. So there's really never any need to manage the underlying cluster. It gets installed and configured for you with the Exchange tools. So in my opinion, I don't see a reason to I don't see a reason not to use this. The only call out I've heard is some backup vendors require that when it's backing up a DAG, it requires you to have a CNO. So just check with your backup vendors first if you're using that kind of solution. But again, this is enabled by default in Exchange 2016. So if you just say new database availability group, there's nothing special you have to do. It'll utilize this by default. So I use this with all my DAGs. Witness server placement. The big change that came in 2013 now was the ability to place your witness server in a third site, effectively creating automatic site switchover, right? If either of your sites fails, whichever one's still up and alive and able to talk to the file share witness, it'll survive, right? And we'll talk here shortly about Azure placement options, and actually some of the options we may have in the future with some new 2016 clustering features. But long story short, if you have a single data center, you already know where you're probably going to place your file share witness. You're probably going to place it there. If you have two data centers, you have the option of picking one to choose which data center is going to survive if the WAN link goes down. Or you use the relatively new option of third site witness. Who here is using a file share witness in a third site? Anybody? Decent amount of hands. Okay, cool. So the Azure hosted witness option. Who here is running this right now? File share witness in Azure. Okay. It has some downsides because you have to effectively stretch your AD deployments into Azure. You have to put a domain controller in Azure, you have to configure the networking requirements, and you have to have your file share witness. Bit of a pain. It does work though. High-level steps is configure the networking components, configure the actual virtual machines in Azure, so your domain controller and your file share witness. Tell Exchange to use it, and then validate and test the heck out of it. Again, at the end, we'll talk a little bit about a new upcoming option, not tested and validated yet, but I'm really excited about it. It's called Cloud Witness. So DAGs on infrastructure as a service. Golden rule here is all regular supportability requirements must be met. So the hypervisor has to be supported, and when using Azure, the Exchange storage volumes for databases and logs have to use premium storage. Jeff Mielef gave a really good session on this. I believe it was either the last Ignite or it was the MEC in Austin. And it just talked about it can be done. It's rarely cost effective to make your entire Exchange deployment in Azure. It's never going to be cheaper than 365. But it is useful for certain deployments, like possibly stretching a DAG up into Azure. Of course, the downside here is always sizing. It's hard to have a one-to-one correlation between the horsepower in the hardware you have on-prem compared to what's going to be in Azure, right? So the operations there may be a bit challenging. Again, I recommend checking out, go to Channel 9, check out Jeff's session on Exchange on infrastructure as a service. Not much has changed here in terms of supportability. Oh, also, Jeff had a really good session this week on ExpressRoute and Office 365. So if you're interested in using ExpressRoute along with 365, when the recording goes live, probably in a day or so, that's the rate they've been going at recently, check out Jeff Mielef's session on ExpressRoute and Office 365. There's also been a few really good sessions around networking and 365 that I highly recommend. All right, moving on into some best practices and tips. Multiple databases per volume. Show of hands, who's running multiple databases per volume? Good amount, okay. So some customers still ask, like, what are the real benefits of this, right? Well, one is obviously the best utilization of capacity, because if we're using, larger capacity drives like 8 terabytes, which are fairly common now, remember the maximum database size, recommended size, is still 2 terabytes. So you won't necessarily see one large database there. So to make the best utilization of the drive, you'd want multiple databases on it. So to give you an example of a benefit people don't always think of, this is when we do reseeding. So say I hope you wouldn't have this, but say you had one 6 terabyte database on one of these drives. But then you compare that to having 4 1.5 terabyte databases. Still have 6 terabytes of total data, right? Well, if the 6 terabyte database failed and it had to be reseeded, it can only reseed from one source at a time, right? So it's actually going to be source constrained in terms of the throughput and performance it's going to get. So let's say it can only achieve 25 megabits a second in terms of seeding performance. It's source constrained there. But if you had 4 1.5 terabyte databases, that drive fails, and you have to reseed those 4. You can reseed from 4 different sources, ideally on 4 different servers, so you're no longer source constrained. So instead of just seeding at 25 megabits a second, we can seed at 25 times 4, 100 megabits a second. We're still reseeding 6 terabytes of data. We're just doing it from multiple sources. So you're going to achieve better reseeding performance by utilizing this method. So the multiple database per volume gives you the best balanced utilization when it comes to capacity, I/O, and reseeding throughput. Let's talk about scale for a little bit. You can talk about it at the server level or at the DAG level. We'll do both. So I think it's fairly common knowledge about the current server recommendations stating you don't want to scale higher than 24 CPU cores or 96 gigs of RAM. There was a great session on troubleshooting Exchange performance with Jeff Mielef and Nasser Ali that was earlier this week. I highly recommend that for later viewing. It talks about this in detail. But these numbers are based on the best performance and stability seen in Office 365, as well as based on some escalations Microsoft has seen from customers. And the guidance really is size at this scale, and if you see performance issues, depending on how heavy Exchange users your environment has, you may just need to scale out, add more servers, spread that mailbox load into new databases. And by all means, if you have to do that, try to use the Exchange calculator to help you in that scaling out. Now at the DAG level, this is one of those interesting topics because I've heard a lot of arguments on either side about should I create a bunch of smaller DAGs or should I create one DAG, scale to 16 nodes, and then create a new DAG and scale to 16 nodes. Microsoft prefers the scale to 16 node approach, and I do too, just because there's some really good arguments there in terms of it giving you better overall availability. So from a quorum perspective, the cluster can stay up longer because it has more nodes, especially when you factor in dynamic quorum, which we're about to talk about. But the example I like to use is, say you have an environment where you have 2 3-node DAGs. Compare that to an environment with 1 6-node DAG. In both scenarios, there's 6 servers. And in both scenarios, each database has 3 copies, right? So in the environment with 2 3-node DAGs, if I just have 1 server fail, that 1 server failure has now affected every database on that DAG. Remember, it was a 3-node DAG, and each database had 3 copies. So 1 server failure has now affected the availability of every database in the DAG because it's lost 1 copy, right? But if I have a 6-node DAG, again with every database having 3 copies, in a 6-node DAG, 1 server failure is only going to affect some of the databases. So the logic applies as you scale out larger as well. So when you get to a 16-node DAG, the failure or the maintenance of 1 server is less impactful. So I like that approach. So does Microsoft. So if you're looking for which way should we go, that's a great suggestion. Some customers run their operations just fine at smaller scale. That's certainly their prerogative. And one other note Ross mentioned in the architecture session earlier in the week was that he always prefers a balanced configuration. So if you have 4 nodes in one site, have 4 nodes in the other. And by all means, especially, I've still seen a couple deployments like this, never do 1 node in one site. The reason there is if a database fails, you have to reseed over the WAN. Right? Always have at least 2 nodes in a site. So dynamic quorum. So when I'm teaching clustering and quorum, I often ask the students, if you think about the word quorum, what does it mean outside of technology? Forget IT, what does it usually mean, right? And the answer is often, it's the minimum number of votes needed to conduct business, right? So your homeowners association meetings, your city council meetings, it's the minimum number of votes that need to be present to still conduct business. So in a cluster, the idea here is we need a minimum number of votes in the cluster to be present for the cluster to remain running. And if you think about a cluster, a Windows cluster, its goal is always to be to stay available as long as possible while always ensuring that we never encounter the dreaded split brain scenario where you have the same instance running in 2 places at once. You would never want a SQL database mounted in 2 places at once. You'd never want the same Exchange database mounted and active in 2 places at once because that would create data divergence, which is a bit of a nightmare to recover from. So if we look at the purpose of a cluster being stay available as long as possible while not having split brain, let's talk about quorum historically, how it worked before dynamic quorum. So here we have a 16-node DAG, 8 nodes in each site, and a file share witness in the center. If we have a WAN failure, in this scenario, one of the servers on the left reaches out to the file share witness and places an SMB lock on the file share witness file. That's really all it's used for. There's nothing else in there that it really needs to do. There's no data there it needs. It just places a file share lock. And what that does is it gives it an additional vote. Because in a 16-node cluster, there's an even number of votes. So we need a tie-breaking vote. So when you have an even number of nodes in the cluster, you would use a file share witness to serve as that 17th vote. So in this case, you need a majority out of 17 votes, and that would be 9, right? So in this case, the 8 nodes on the left are able to contact the file share witness and get the 9th vote. So they now are in the majority, and they'll stay up and running. The nodes on the right are going to lose quorum and shut down. They say, hey, there's 8 of us here, but we're still in the minority. That means there's a possibility that there's a majority somewhere else and they're running the service. We need to shut down so that we avoid data divergence, right? So here now we're a 17-vote cluster and we have 9 votes on the left side. But what happens if we lose one more server or some unfortunate junior admin reboots the file share witness during this extended outage? Well, we no longer have a majority of votes. We only have 8 out of a 17 vote. We lose quorum in that site and the entire cluster goes down. So we no longer have a majority, we have to shut down. So what about dynamic quorum? How can this help us? Remember, dynamic quorum is a clustering feature, it's not an exchange feature. Same scenario, 16-node DAG, we encounter a WAN failure. Same things happen. We go out, we talk to the file share witness. The side on the right gets the 9th tie-breaking vote. Right side goes down. So what dynamic quorum does is it says that if the initial failure results in me still being able to maintain quorum, well, the cluster's done its job at that point. But what can I do now to increase the lifespan of this cluster, to keep it up longer? What if I can dynamically adjust the votes in this quorum? How about I take it from being a 16-node cluster with 17 votes? What if I turn it into an 8-node cluster with 9 votes? Well, in an 8-node cluster with 9 votes, 5 is what I need to maintain quorum. So if I lose another server, I stay up and running. In fact, I can lose several more. And actually, as long as those subsequent failures result in quorum being maintained, dynamic quorum can do its job again and keep going. Just note that the Exchange product team, their recommendation is that this Exchange doesn't know about dynamic quorum. It can just benefit from it under the hood. It exists at a lower level than Exchange does. So they say while it can help you, and it should help you, don't always count on it in your disaster recovery planning. It's one of those, it's a plus. It's gravy, right? So I don't want to sell it too much here. It should be a great feature. It's enabled by default when the DAG is created because it's enabled by default in clustering. Just don't always count on it because it does matter how that first failure happens, right? If the first failure happens and you lose quorum as a result of the first failure, if enough nodes go down, it can't help you at that point, right? So database copy layout and preferred DAG design. It says preferred, makes people think preferred architecture, but you don't have to perfectly align with preferred architecture for this. Don't leave resources unused on a server. You paid for the hardware, use it. Old clustering had an active-passive approach where you had a certain set of servers where resources were activated on, and a certain set of servers where there were no resources on there. They were passive, right? Unfortunately, you're wasting the hardware on the right. Active-active would be where you have an even distribution of active mailbox database copies across all servers in a cluster, in a DAG, even if some are in a different site. We'll talk about some of the client connectivity changes under the hood that make that workable, right? The idea here is balance. You want balanced load because remember, starting with Exchange 2013, all client connectivity ultimately has to find its way to wherever a user's mailbox is mounted, right? So even if you're doing load balancing at the client access layer, all your connections are ultimately going to these three servers where you have all the databases mounted, right? So you're not achieving a very good distribution of load. Let's look at that visually. So here we have a 6-node DAG. We have 9 databases, DB1 through DB9. The green ones in the upper left-hand corner are the active ones. There's 4 copies of each database here. In this scenario, not only do the 3 servers on the left handle all database and performance load, they're also handling all client connectivity load as well. So even if you're load balancing to the other servers with the CAS components, everything's ultimately going to these 3 servers. And that would also mean that if those 3 servers failed at once and had to be brought over to the other site, that means you'd have a very quick and sudden surge of connectivity. So in some cases, you might even see those servers not able to handle that drastic increase in load. But here we have an active-active design. And remember, in the Exchange calculator, when you're picking your layout, this would be active-active, right? So active databases evenly distributed amongst all 6 nodes in this DAG. So we have here a more balanced distribution of load from both the database performance perspective as well as the client connectivity perspective. And if we have a server failure, we find that we have a little more balanced distribution of some of that load when it does happen. If I have another failure, again, a more balanced distribution of this load. And the calculator can actually help you get this layout. If you look, that's kind of what it wants you to do when it gives you the preferred database copy layout. The idea here is an even distribution of load and a balanced distribution of that load after you encounter failures, right? Really, if you think about it, this is the only way you can really manage a service like Office 365, right? You need balance, you need scale, right? So how does it affect client connectivity? So before Exchange 2013, there was a lot of cross-server RPC traffic. And this is a change I think got overlooked somehow, because to me this is one of the biggest changes in the product with 2013. We got rid of almost all RPC communications between servers. And RPC was not very good at latent connections. Wasn't good at handling latency, wasn't good at handling cross-site or cross-network traffic. Outlook clients are all HTTP now. Outlook Anywhere or MAPI over HTTP. And HTTP was meant for an internet or WAN workload. So it's more tolerable of those kind of connections, right? So should I care if traffic crosses over a WAN? I like to tell a story of a customer where we deployed Exchange 2013 in a New York site and a Florida site. Deployed it, everything was fine, but shortly after, over the span of a week or two, they had some network issues that were causing some failovers in the environment. And over the course of that week, databases would fail over, they'd be different servers, different sites, but the funny thing there was they didn't receive any help desk calls from their clients about how their connectivity was poor or how they were getting bombarded with prompts. I mean, if it's configured right at the client access layer, a mailbox should be able to connect over the WAN. I mean, we're talking reasonable, latency setup here, reasonable WAN design. And as I mentioned, there were some really good sessions earlier in the week about Office 365 and client connectivity, which you can take some of that information and apply it to your own environment. So should I really care? Well, it's always ideal to have a closer connection, but think about it. In Office 365, users are constantly traveling around the globe and accessing their mailbox, and the connectivity isn't horrible if they're not in the same physical geographic location, right? So while you can try to have preferred locality using geo load balancing and other solutions such as that, it's not a hard requirement, right? The product, the 2013 and 2016, was built for cloud, and this is one of, in my opinion, the biggest features that was introduced in the cloud that we saw on-prem. Better client connectivity and the almost complete removal of cross-server RPC communications. Okay, a few tips here. I've seen customers get bit by this one. Has anyone ever encountered the data move replication constraint issue before? Well, maybe I should have removed the slide. No one's seen it. What this says is that your DAG cares about the health of the copies when you're moving mailboxes around. The idea here is if I'm going to move a mailbox from one database to a different database, the mailbox replication service can talk to the DAG and look at the health status and see, all right, if this destination database that I'm moving the mailbox to, is it in a healthy state? Does it have at least one passive copy that's healthy and up to date and has the relevant transaction logs replayed into it? Because if I'm moving a mailbox here, I want to make sure that the database is healthy and has all the transaction logs that included that move. So sometimes what you'll find is a move request will stall and it won't complete. And if you run get move request or get move request statistics, you may see it talking about data move replication constraint. So this is a property of the mailbox database. And in a DAG, the default is second copy. And that will state that at least one copy of that destination database needs to be in a healthy state before I'm going to complete the move. You can certainly change it to none if you want to, but ideally, you should just let it do its thing. Let it sit there, and ideally, your DAG will become healthy. Ideally, that you'll have at least one copy that's in a healthy state. So I would say try to fix the DAG issue first. If for whatever reason you don't think you can, you do have the option at least of using set mailbox database and changing data move replication constraint to be none. So I would never want to insinuate that there's a history of bad blood between Exchange folks and storage folks. But whether you're running preferred architecture or you're running virtualized on SAN or physical with SAN, it's good to know how Exchange is going to behave when it encounters storage issues or performance issues. So have the most ammo you can have on you when your customers come to you saying, Exchange went down. Why did it go down? Well, maybe it's not an Exchange problem. Maybe it's a storage problem. So again, you have this link here. You can download the slides because this, I'm not going to cover this whole, this whole thing at once. You can take a photo if you like, but you can access it later. But these are some of the behaviors that Exchange will show if it's having storage or perf issues. For example, an ESE database hung I/O for longer than 240 seconds will result in a log being generated and the server being rebooted. Because remember, this is a DAG, right? If a server is incapable of handling I/O, we don't want databases mounted there. We want to take the quickest action we can to get those databases mounted on a healthy server. Because that's ultimately what we care about is the client experience, right? Other things that can happen, server OS hang. I actually see that more when you virtualize, just because it's people maybe overcommit resources when they shouldn't, or they didn't follow the virtualization best practices, and that can result in a complete OS hang in some cases because there's CPU overcommitting, there's contention, and you name it. Another scenario would be replication service using too much memory. Each of these can result in a server being rebooted, and people may think it's Exchange's fault when maybe it's a storage problem under the hood, or maybe it's some type of virtualization problem. Other possible causes, obviously, our old favorite antivirus could be, filtering I/O or hanging I/O. Remember, just about every antivirus product puts a filter driver in the file system stack. If you run the command fltmc, it's a Windows command, been around forever, you'll see all the filter drivers in the file system stack. Those could be causing delayed I/O. Or maybe if you're using SAN, if you're doing a controller failure and it's taking too long, I've seen that cause it as well. So just, as I said, be familiar and have as much ammo as you possibly can when you're confronted with issues that are possibly outside your control, making your baby look ugly, right? Transport high availability. So a lot of people confuse what shadow redundancy is meant to achieve and what safety net is meant to achieve. Shadow redundancy, its goal is to ensure that in transit there's at least 2 copies of every email message. That way if one fails in transit, it can be resubmitted. Safety net works with the transport stack, but it's really a high availability feature. The goal of safety net is to keep a copy of email that's passed through the transport database, and if the DAG encounters a lossy failover, meaning database fails over and we missed a few transaction logs, right? Safety net, it's what its name implies, right? It's a safety net underneath you to help you. So if you were to lose some transaction logs, the DAG is smart enough to query the transport database and say, hey, give me everything that passed through transport for the last X number of days. By default, it's 2 days. And you won't be able to see these messages. Shadow redundancy you can see because you've probably run git-q and you've seen the shadow queues. That's a little different. Safety net you can't see. It's in a hidden table in the transport database. But what this results in is your transport database file being quite large. And if you're using a lag copy, the recommendation is to have the safety net hold time equal the lag time. So if you have a 14-day lag, you need to set safety net to 14 days. And what does that mean? A potentially huge transport database. In fact, I had a customer that was doing preferred architecture with a lag, a 14-day lag, and in the calculator, people always seem to miss this field in the calculator. Under the, I think, storage requirements area, I forget, there's a transport database space required section. In one customer's case, they needed a 1.5 terabyte transport database, meaning they had to define or create a separate set of spindles. They did a separate RAID 1 just to host their transport database. So just be aware of the sizing concerns around safety net. If you're going to follow preferred architecture and do it that way, you need it to size appropriately. And obviously, if you're not using that, safety net can still help in a pinch in a DAG. It can be modified using set transport config to whatever value you like. All right, Exchange and the Windows Server 2016 HA feature. So a lot of the coolness that you've been reading about this week, how does it play in with Exchange? Whether you're doing preferred architecture, whether you're virtualizing, what have you. So a few of the new features are going to align with the preferred architecture. So if virtualizing, though, there's some that may look a little exciting. Of course, I don't know how many, I don't think the product team is actually here, so in theory, I could just say the world is supported. Y'all want to run a file share witness on Windows Mobile? Go for it. Y'all want to stretch your DAG to a Windows 10 VM? Go for it. Hey, data center mobility, baby, right? Please don't listen to any of that. I don't want the lights to cut and them to debadge me and take me out of here. Just know that the Windows Server 2016 is still very new. And while the product team has supported Exchange being installed on the OS, that doesn't mean they've had time to fully test to their liking all of the new features. Jeff Meliff, in one of the panel sessions earlier this week I was in with him, he stated that in the service, they don't always necessarily do the latest and greatest, and that the service is where they test the product fully, right? So they just haven't had a chance to test some of these features. So what are the features? Well, I mentioned Cloud Witness. So the reason a lot of folks don't really do the File Share Witness in Azure is because it's a little complicated to set up, right? You have to put your domain controller up there. You have to configure the VMs. You got to pay for those VMs to run. Cloud Witness is a new Windows Server 2016 feature that allows you to use this Azure object. A Cloud Witness, think of it as just an Azure object that exists up there that you can just point your cluster to and say, hey, use this as a File Share Witness. Kind of like a URL it gets pointed to, right? Think of it that way. And this makes it very easy to use a third-site File Share Witness because you don't have to put a domain controller up there. And I actually heard from one of the Microsoft PMs about when they were testing this feature, they struggled to get it to use like $1 a month. Because think about it. Your cluster only ever uses a File Share Witness in a failure scenario, right? And when it does, it goes up there and just does an SMB file lock on it and says, hey, I have another vote. Isn't that grand? So it's very cheap, very easy to deploy. Problem is it hasn't been tested and validated yet, but I know Jeff is really excited about it, and he couldn't promise anything. But in my opinion, that's probably the most exciting new feature that people can take advantage of. Other features, Storage Replica. I love Storage Replica. It's a very cool feature. As someone who also does general Windows support and some virtualization and performance stuff, it's very exciting to me. But Official Answer is not supported at this time. It's kind of in that same world as Hyper-V Replica, where you're replicating at the block level, but the Exchange product team either has some concerns or they have testing and validation that would need to be done. So as of right now, not supported. Whether they are or aren't, can't say. Remember, the Exchange product team, and this is really every product team at Microsoft, they can only really support something if they've tested it and validated it. And also if it just makes sense. Some things just don't make sense for Exchange. So with my opinion here, Exchange has invested quite a lot in its own built-in HA features. So I wouldn't be surprised if they weren't immediately ready to jump at a new technology. This is like the when is SQL coming to Exchange conversation. It's like, well, we spent years working on ESE and customizing it for our needs and achieving the HA we want. So again, future, who's to say what can happen there. Virtual machine storage resiliency, no support statement yet. What this feature is if you have a virtualized 2016 virtualized cluster, if you have a particular VM that's experiencing I/O issues, instead of immediately failing it over, it can pause that VM instead and wait for the issues to go away for a predetermined amount of time. Well, in my opinion, if you're virtualizing DAGs, you should let the DAG handle when it needs to fail over. I mean, all the keep alives that get sent between DAG nodes, it's very sophisticated, it knows how to do its job. So in my opinion, I wouldn't be looking at this feature for Exchange VMs, but still, no support statement as of yet. Lastly, production checkpoints. It's the same story as before with traditional checkpoints. It's not supported at this time. I'm not sure why it would be supported, but who's to say what the future would hold, right? My opinion here, it's the same it's always been when you're talking virtual machine checkpoints. Is Exchange has some of its configs stored locally on the server and some of its configs stored in Active Directory. You really don't want either of them to go forwards and backwards in time, right? If you're running a lab and you want to use checkpoints, fine. Just make sure you take them at the same time and you revert to them or apply them at the same time. But production, not going to be supported. And really, that's it for the session. I actually have a bit of swag up here if people want to ask questions. It's a gig USB stick that has a copy of Office 365 for Exchange professionals on it, if anyone's interested in those. It's a good book from Tony Redman, Paul Cunningham, Michael Van Hornbeck. Actually, I also published a book with Paul Cunningham on Exchange Server Pro's sites, Exchange Troubleshooting Companion, if you're interested. But again, got some swag here. Any questions? I'll try to answer them to the best of my ability. I Thank you for your attendance, and have a safe trip home. I'll stay for questions, though. I know people have to run. It's Friday. Yes, sir.
Yeah, I had a question about the CU3 content index changes. Actually,
Yes, sir.
two quick ones. First is we've all had content indexes go bad and had to refresh them.
Yeah.
Is it just with the new CU3, do you just stop the search service and wipe it and just let it rebuild on its own, or do you reseed it? How does that work now?
Well, I've actually found, in my experience, with 2013, really, if you give them enough time to fast, and the search components are pretty good at self-healing themselves. So nothing changes here in terms of how it handles repair operations and things such as that. It's more of a during normal operations when I go and I actually get the data where I go to do it. So if a local content index was in a failed state, it would just, on a passive copy, it would just be looking local to that passive copy to heal itself.
Okay, and that kind of brings me to the second question. There's not really any free lunch. So if we're getting better network performance, it seems to me that by shifting the load over to building the content indexes locally, you put yourself in a situation where maybe you have more CPU, where the search service is having to crawl on the disk more. Is that what you guys have seen? Is that something we need to consider? Is it part of the...
I don't believe the calculator has anything. Use the calculator, obviously, in terms of your load design. And again, it's all assuming CU3 is deployed. In terms of additional CPU load, I would almost think it'd be a little less, because instead of going over the network and using some CPU from the network point, it'd be local processing. I don't know any official guidance saying it is going to happen. Is any product group members here to say if you've noticed that in the service? Because as far as I know, I think the calculator would account for any CPU changes. So.
Okay, thank you.
I can get your USB key if you want it. Yes, I'll just go rotate here. Dave?
Hey, Andrew. So I got an actual question, but I also got a dare.
A dare?
Yeah, to mention on-premise as often as possible.
On-prem as often as possible?
No, on-premise.
Oh, did I say on-premise?
No.
Oh, okay. Yeah, it's a stickler thing for a lot of us, on-premises versus on-premise. Premise is an idea. It has nothing to do with location. It's just one of those things.
But, well, actually my actual question is about the Azure-hosted file share witness.
Yes, the new one, or the traditional, like as it stands right now?
The traditional one. Well,
yes, sir.
It is a bit related. Will it be supported with an Azure domain services? Because you, in the diagram, you had a domain controller in Azure. And you have Azure domain services in preview, I believe.
Yeah, that would be your own domain controller as a VM that you've put in Azure. I don't believe Azure AD is an option that's explored at the moment. I think I know Jeff Mielef had a session on Exchange and infrastructure as a service last year. I can't answer that of what they're looking for right now, but I don't believe it's an option at this moment. I mean, when you're using DirSync, you're using Azure AD if you think about it, but this is just this is extending your on-premises environment to Azure, not necessarily using it for directory services.
Right. Well, and obviously the future option will be the Cloud Witness version. Yeah,
I mean, that's the way to go in my opinion. And I don't see why it wouldn't be a supported option going forward, to be honest. But
right. Well, I know that you don't have anything to say about it, but I was wondering, because there was the slide for Cloud Witness was on Exchange 2016, and will it also be supported on 2013? I know you can answer that, but I just wanted to put it out.
I wouldn't see a reason why the requirements would be different there.
Right.
Personally, is my perspective. If Jeff Mielef were here, he would say the same thing with 2016. There's work to do, and we'll talk about it when we're ready.
Okay. Thank you.
Thanks, Dave. Yes, sir.
So you mentioned the DAG activation preference behavior change.
Yes, sir.
So just a question. So right now it's based on the preferences of the Exchange admin. So you take your copies and you number them, 1 through whatever.
Yes, sir.
Do you know if there's if it's a change is coming down the pike, say based on load, where it's going to do some type of intelligent evaluation of your servers and say, based on load, we're going to fail the copies over to this particular server.
Yeah, well, I know in 365 they actively monitor a lot of that, and their solution is you can shuffle the mailboxes around per se. I mean, the activation preference, it's just that, it's a preference. When it comes to best copy selection in a failure, which copy is going to be activated, there's other factors that are involved, like if it's up to date in terms of copy queues, replay queues, and things like that. So in terms of which one gets selected, there's a whole set of logic there that doesn't look at performance.
Okay.
In terms of what's coming, who's to say? It may be another feature we see from Office 365 and gets put down to us. I think this was an Office 365. I think they announced it as an Office 365 feature that they used for balancing. So I guess we'd have to stay tuned and see what the product team says about that. Because right now they just monitor performance and maybe shuffle around their different tiers of mailboxes as needed.
Is there like a lull in activity? So when you said it was like every hour it does a check.
Yeah, every hour it'll basically say, is the database is activated on their preference of 1, yes or
Right.
no. If not, move it.
Okay. I'm just wondering, does it have to be like a lull on that server before it makes this failover? No?
No, it's just time-based. So default an hour. You can set it to longer if you would prefer.
Okay.
Cool. Here, get your swag. In fact, I mean, some of y'all in the front row, hey, you were nice enough to sit up here. You're welcome to get some if you'd like. I mean, yes, sir.
I just wanted to confirm that I heard it correct. So in a file server witness where we have it in third data center and the link between two data center goes down, shouldn't the database on both
I'll get some for these guys.
both data center be still active, or is it going to be
So
whoever gets to the file server first, that site will be active?
Yeah, here, I'll hand these to y'all since y'all were in line. It all really depends on the underlying networking at a logical level, right? If you were in a scenario where you had a failure between the two sites, but both could still reach the file share witness, if that's how your networking works under the hood, it would be, first to get there. But in a lot of cases I've seen, it's rare that if they can each get to the file share witness network, they can probably get to each other across the file share witness network, right? But it depends on the networking. Maybe they don't.
So no, we don't have it that way, right? So we have a 10 gigabit link between two data center, and each offices has 100 meg link to both data center connecting directly, right? So in that scenario, if the 10 gigabit link goes down, so file server witnesses is still visible by both data center, and not necessarily both data centers see each other. Make sense?
Yeah, then it is the first one to place the SMB lock on the file share witness that would win.
So there'll never be a scenario where even all of them are up and running, they will not be, database will not stay where they are if the
Correct.
link goes down.
Yeah, I mean, if the link goes down, it all comes down to the cluster nodes being able to talk to other nodes in the cluster. Is there enough of us to have majority? If the answer is no, and we can't get additional votes to achieve majority, then they'll shut their cluster services down.
Okay, thank you. I'm
problem.
clear now. I asked that question in many different ways.
No, it's all right, no problem. Yes, sir.
So I recently had to reseed a database over the WAN,
Yeah.
and I haven't done it in a while, so maybe the problem was there for a while and I just haven't seen it, or last time when I did it, maybe I didn't pay enough attention because the database was smaller. But essentially the speed of replication that I got was a lot smaller than the throughput of the pipe. And essentially I was replicating at about like 20 megabits per second. And I didn't find any articles online that would essentially say that something is getting throttled. Essentially everything said, it will utilize the entire bandwidth that's available to it.
Yeah,
But I don't know, have you ever seen it? Do you have any ideas why it was so slow? Is it normal?
Well, so replication uses a little different technology than a seed. So replication, you're copying the transaction log files over the network, or you're using block mode replication, which is
Yes,
just...
I was specifically asking about the reseed operation.
Yeah. Seed actually uses the old school ESE streaming backup method. So it's not just you can make the best utilization of the wire, it's the bits itself, what they're capable of. And actually, when I talked about multiple databases per volume, I referenced that 25 megabits a second throughput. That's actually not a number I made up. That was a number that the product teams used in past blog posts, and that Ross Smith said that that's typically what they see from
Gotcha.
one particular source.
So
there-
this
there's-
was normal because I didn't see a bottleneck anywhere on the server, on the storage layer. So you're saying that this is normal, right?
Yeah, 25 megabits a second is what they would deem reasonable, and that's probably the way the code's written type of
Okay.
constraint.
All right. Thank you.
No problem.
Also kind of WAN related, there has been no change in the DAG replication architecture. It's still a pure star. Have you heard any discussion about optimizing that for expensive links, kind of going back to a bridgehead model to,
The dream of chained replication. Yeah, this one's been around since 2010. The idea that well, maybe you could have like a server you replicate to that one, and then that one replicates onward. It's been a request. I've seen it on a lot of the MVP and MCM distros for a while. Could that be changed? And from what I've heard, there's no plans to do that, unfortunately. So what we get now, and with compression and the performance we get now, as it stands at the moment, it's probably going to stay the same.
okay, I mean, we got decent benefit out of WAN enhancements like Riverbed, but it'd be nice if it was product included anyway.
Yeah, well, I mean, with 2016 CU3, hopefully that'll alleviate some of that concern with some of the savings there with your indexing. Because remember, a lot of your traffic so far has been with content indexing, not just the replication itself. Yes, sir.
Question here. I have a 3-node DAG group at my site. I have 2 nodes in my primary, 1 node in my DR site. One of the things we have to do is we have to do a failover test. And what we do there is, what I currently do, I cut the link, the single node in my DR site, I run a bunch, well, first what I do is I shut it down, I make a snap of boot drives, database drive, logs drives. And so what that does is allows me to bring up, if you want to call it a ghost copy of that 3rd node. I then run a bunch of commands. It massages failover cluster, gets that up, gets the databases up. We test, do whatever, send emails, do whatever. And then when we're finished, we shut that server down, discard those copies, reconnect the original boot drive, the original database log. We bring it back up, and then we restore the link. And as far as the other 2 in the primary site, it's still serving mailboxes. Everybody's working.
So this whole time, it's like, production's still there. You're just doing an exercise on the DR side, right?
Yep.
Okay.
So, and my question is there anything in 2016 that helps, I guess mainly eliminating the whole shutting it down, creating snaps, just so I can bring it up and, screw around with it to get it up?
Well, I mean, the solution it doesn't align with the preferred architecture, so you're probably not going to see a whole lot of enhancements there per se, and probably going to get shot for saying this. Is this virtualized or is this physical?
All physical.
Okay, say maybe the production checkpoints would be an option if this is just a exercise, right? I can't think of anything immediately that would help in that type of testing scenario. If it was virtualized, I could see you just taking a
Yeah.
production checkpoint of the VM, which is the production checkpoints. The thing that's different about traditional checkpoints is they integrate with VSS, and they can kind of quiesce IO and make it a more graceful checkpoint. So if you were to virtualize on the other site, I could potentially see that it being a little easier to take that
easier to do.
snap. Yeah,
Okay.
that's a good point.
All right. Thanks.